You know, when we think about scientific breakthroughs, we usually picture these huge eureka moments, right? Big, flashy discoveries. But honestly, some of the most important ones, they're more like a whisper. They happen so quietly you don't even notice, but they end up changing, well, pretty much everything. I mean, just look at the screen on your phone. How does it get those incredibly vivid colors? Or think about this. You get a headache, you take a pill, and poof, the pain is gone. Seems totally unrelated, right? Well, what if I told you the hidden connection between them is the exact same science? It all comes down to the teeny tiny molecules that make them work. So today, we're going to pull back the curtain on one of those amazing, quiet discoveries. We're going to talk about the scientists who basically wrote a whole new chapter in the chemistry books, a chapter that, believe it or not, affects your life every single day. Okay, so those brilliant little pixels on your phone, they're called OLEDs, organic light-emitting diodes. And that active ingredient in your medicine, also an organic molecule. See the common thread? It's the word organic, which in chemistry just means they're built around carbon. And without the ability to build these special carbon-based molecules from scratch, our modern world just wouldn't be the same. But here's the catch. Actually, putting these complex molecules together is ridiculously hard. I mean, for decades, it was one of the absolute biggest challenges in all of chemistry. And the field dedicated to this is called synthetic organic chemistry. I love this definition because it calls it both an art and a science. And it really is. You have to have the creative vision to dream up a brand new molecule, but then you also need the hardcore scientific skill to actually make it happen in a lab. So this is what a chemist's life looks like. First, you draw up the blueprint for the molecule you need. Then comes the really tough part. You have to actually build the thing, piece by piece, because it doesn't just exist out in nature. And finally, you have to purify it, which means getting rid of all the junk that got created along the way. It is a slow, painstaking process. So what made it so darn difficult? Well, for a long time, molecules were, let's just say, stubborn. They just didn't want to connect in the right ways. So you'd end up with this messy soup of unwanted byproducts. And after all that incredibly hard work, the actual amount of the good stuff you made, what chemists call the yield, was often minuscule. It was just a super inefficient, super expensive headache. The world was crying out for a better way to do this. And then, back in the 1970s, 3 scientists, all working on their own, found it. And their big breakthrough all hinged on one very special, very powerful catalyst. It was this incredible burst of scientific creativity, all happening within about a decade. You had these 3 chemists, Richard Heck, Ei-ichi Negishi, and Akira Suzuki, and each one of them developed a totally game-changing new chemical reaction. They basically gave the world a brand new toolbox for building molecules. And this is a quick breakdown of how they did it. So each scientist used a different key ingredient. You can see them here: halides, zinc, or boron. But the secret weapon they all shared: palladium. You can think of palladium as like a chemical matchmaker. It grabs the 2 different molecules you want to connect, brings them together perfectly, and then it just lets go, completely unchanged, ready to do it again. It made the whole process unbelievably efficient. And here's something that just blows my mind about this whole story. One of the scientists, Akira Suzuki, he could have patented his discovery. He would have become unbelievably wealthy. But you know what he did? He didn't. He chose to give it freely to the world, just so science could move forward faster for everyone. That one decision, wow, it was a total game changer for the entire field. All right, so we've got these amazing new ways to build molecules. But how do we get from a reaction in a lab flask to the phone in your pocket or the pills in your medicine cabinet? Let's connect those dots. Honestly, the difference was like night and day. Before this breakthrough, building molecules was kind of like a shot in the dark. It was unreliable, inefficient, and you barely got anything to show for it. Afterwards, it became a precise, reliable science. This wasn't just a small improvement. It unlocked a universe of new possibilities for chemists. It unleashed enormous progress. And for that enormous progress, for literally changing the entire field of chemistry and making decades of innovation possible, the world finally took notice. In 2010, Richard Heck, Ei-ichi Negishi, and Akira Suzuki were awarded the Nobel Prize in Chemistry. And that brings us right back to where we started. Their Nobel-winning discovery isn't just some abstract theory in a textbook. It is the direct reason we have the incredible technologies and life-saving medicines that, let's be honest, we all kind of take for granted. It's chemistry that you can actually hold in your hand. So when you look back, What's the real legacy of these scientists? Well, it's a story about how quiet, focused, dedicated work can create these massive ripple effects that end up touching every single corner of the globe. I think this says it all perfectly, doesn't it? The thousands of hours they poured into their work in the lab, perfecting these reactions. They have literally helped illuminate our world through our screens, and they've improved our lives through better medicine. And maybe the biggest lesson from their story isn't even about chemistry, it's really a message for all of us. It doesn't matter what you do. If you really devote yourself to it with focus and passion, your work can have an impact that you can't even begin to imagine. Which kind of leaves us with one big question, doesn't it? Right now, at this very moment, there's someone in a lab working on the next quiet discovery, the next whisper. So, what do you think it is? What's the thing we're not hearing today that's going to become the bedrock of our world tomorrow?